Hey, everybody, and welcome back to another episode of the Ruby Rogues podcast. This week on our panel, we have Valentino Stoll.
Hey now.
John Epperson.
Hello, everybody.
I'm Charles Max Wood from Top End Devs, and this week we have a special guest, and that is Bruno, is it Sutic?
Sutic.
Do you want to introduce yourself real quick? Let people know who you are and why you're awesome?
Sure. Hi, everybody. I'm very happy to be here on the show. So, I've been a Ruby developer, Ruby programmer for, I think, more than 10 years now. Yeah, it's been 11 years now. Actually, before being a Ruby programmer, I started wanting to be a project manager at IBM here in Zagreb, Croatia. But I quickly realized that's not what I want to be, and that's not what I want to become in life. And somehow I discovered Ruby, fell in love with it, and it's been a nice romance since. And yeah, so I think, in terms of my resume or, what I've been doing, it's been pretty standard. I've done some agency work for a couple of years, like three or 4 years. Then I've had another job with a product-based IoT company from Denver. We've been doing internet-connected locks, right? Like a solution where you can connect to your door and do whatever, right? So that's been really nice. And since about 2 years now, I've been doing my own product. I'm starting something and working on it for more than a year now. And I think that's it. I think that's it in terms of I've been finding about async. It's been just a luck. I've been evaluating it for my project. I kind of decided to work in it, to implement it. And I've been working with Async Ruby for about a year and a half now, and I think it's really, really nice. And I think Rubyist and Ruby community really needs to look into it because it's awesome. Async Ruby really is awesome. And I guess we're here to just, kind of get familiarized with it and spread the word.
Hey, folks, this is Charles Max Wood from Top End Devs. And lately I've been working on actually building out Top End Devs. If you're interested, you can go to topenddevs.com/podcast, and you can actually hear a little bit more about my story about why I'm doing what I'm doing with Top End Devs, why I changed it from devchat.tv to Top End Devs. But what I really want to get into is that I have decided that I'm going to build the platform that I always wished I had with devchat.tv, and I renamed it to Top End Devs because I want to give you the resources that are going to help you to build the career that you want, right? So whether you want to be an influencer in tech, whether you want to go and just max out your salary and then go live a lifestyle with your family, your friends, or just traveling the world or whatever, I want to give you the resources that are going to help you do that. We're going to have career and leadership resources in there, and we're going to be giving you content on a regular basis to help you level up and max out your career. So go check it out at topenddevs.com. If you sign up before my birthday, that's December 14th. If you sign up before my birthday, you can get 50% off the lifetime of your subscription. Once again, that's topenddevs.com.
So, Bruno, before we jump in here really quick, just wanted to ask you, you said that you'd been working on a project for over a year now. Is it a secret? Are you telling us what it is? Just kind of curious maybe what it was, if you wanted to say. If you don't, that's okay too.
So about my product, right? So I am kind of holding it to myself. So yeah, it is kind of not really top secret, but like I'm not being open with it.
100%
so
okay.
Hopefully that's okay. That's clear.
Okay then, cool. Sounds great. Let's talk about async.
So there's a lot of async libraries out there for Ruby. What I guess brought you to async in the first place, and what do you think is better about it than maybe some of the others?
It's a good question. It's a really, really good question. Okay, so full disclosure, I do know about other async libraries out there, but I do not have extensive experience with them, right? I've just kind of evaluated it quickly and chosen async, right? Async Ruby. And why async and why not something else is the main developer of async Ruby is a Ruby core committer, right? And there has been a lot of parts required for async Ruby to work really nice with Ruby that have been brought into the Ruby core, right? Into Ruby language. In addition to that, Mats, the creator of Ruby, of Ruby language, has invited and Async Ruby to be a standard library. I guess it's called a bundle gem now, But anyway, Async Ruby has been invited to Ruby standard library, and that kind of piqued my interest. Why is this library more like special than any other library, right? And as I dove into it, it kind of became clear that currently, as things stand, Async Ruby does have a very, very strong support from Ruby core team. What that means is there are a lot of features that have been introduced into, say, Ruby 3.0, Ruby 3.1, into core Ruby that are benefiting Async, the library, the gem. And I think that's it. And so that's one side, of course. The other side is Async Gem itself is really, really nice to work with. I mean, nice as in not nicer than other async, other async libraries in Ruby that are like nicer than work than most other languages out there, right? I mean, I guess the most common async the language that support async and has the asynchronous paradigm is, of course, JavaScript. Like everyone knows that, right? And, I'm going to be bold here and say, look, Async Ruby is much nicer to work with than the asynchronous paradigm in JavaScript. So yeah, it's a really, really nice gem. Yeah, that enjoys the support of Ruby core team. I think that's it.
So what brought you to start using it and experimenting with it?
So as I mentioned, I have my project that I'm pushing, and I needed, some approach to make many HTTP requests in parallel, right? I needed something. And so one common approach is, as I already mentioned, using threads, right? If you want to make 20 requests, HTTP requests in parallel, and then wait for some time for all of them to resolve, you use threads in Ruby commonly. And if you start building your app around it, if that logic gets more complicated, you soon discover that threads really have their downsides when it comes to complexity of handling them, right? I've done threads, raw Ruby threads in Ruby for other things. And let me tell you that is I'm not going to say help. If you know what you're doing, you're going to be fine, but they're complex. Working with raw Ruby threads is complex. And so, I needed something else other than threads to handle, to make many HTTP requests in parallel, many at the same time, and search for solutions. And, async really stood out from anything else that's out there currently in Ruby landscape, right?
So I'm just kind of curious, as we kind of pull this in and start using it you said you're using this on a project, like how easy is it to pull in and implement? And does it really change the way that you think about Ruby? Because it's one thing if it's, hey, I get ABC benefits out of it, but also, it's like, is it a giant pain? Is it, oh man, I got to kind of bend my brain around this other way of thinking, stuff like that?
That's really good questions. Mm-hmm. Okay. So, of course, it depends on what you're trying to do, right? I'd say, a good first, like a task or a challenge for anyone coming into Async Ruby and wanting to experiment with it would be, you have a scenario where maybe you have you want to make an API client and it requires you to have, there's scenarios where you need to make 5 requests in parallel, right? And that's it. You just make 5 requests in parallel, just wait in parallel, of course. And then once you get the, all the results, you make something with it and you're good, right? That's, I think, an easy scenario, right? And I think using async in that case is really simple, right? It just, making a couple API requests, network requests. Once you're done, just work with it in a regular Ruby way. I think that's really, really easy to do. And I guess, another question that could be asked is okay, is that the only thing that async can do? Of course not. In the async core gem, named async, of course, there are a couple more things, a couple more utility classes that are bundled in it with the gem that you can use, right? And so if you decide to move on from that simple network example with 5 requests, I think you're well equipped with Async Gem to handle more complex scenarios. And yes, there's some degree of learning when it comes to, building more complex logic with async. But I think, there are a couple concepts that you need, if you want to go advanced with async, there are a couple of concepts that you kind of want to understand, before going advanced with it. So, I think that's the answer to the question. I could go deeper, but maybe, if you guys want to just steer the direction of the conversation, that would be awesome. I don't want to, I kind of feel uneasy talking the whole time by myself. So, yeah.
Sure. I have a bunch of questions here. I guess one thing I always think about when worrying about throwing HTTP requests in particular, right, and something concurrent, especially thinking about a lot of people think about jobs, background jobs, right? Like throwing a bunch of stuff on a queue and having it churn through kind of asynchronously, right, so to speak, as it pulls things off. But there's a lot of issues, right, where you kind of have to make sure everything can be run again, right? Like if it fails, it'll retry, and you need to be able to say, okay, like build it so that it can run again without any issue. And also, like, if there's one slow request out of the group, does that slow down the whole group? Yeah, as John is letting me know, idempotency for those background workers. But so I'm curious if you're familiar kind of with how maybe async can solve some of these issues, or if there are special considerations you have to consider when using async, or maybe it's not meant for those purposes.
No, that's a good question. Yeah. All right. So I'm kind of thinking what's the best approach to answer this question. So look, I think like if you think about a background queue like Sidekick, the most common one, I think that's just like that's not relatable in a way to async, right? Like async is much lower level library in a way. It's much closer to the core Ruby language. It's just like a more simpler primitive, so to say. It's much easier to compare raw threads with async and, fibers. So async runs on fibers. So those things are kind of comparable, right? If you think about a background queue like Sidekick, I think that's a much higher level library where all these features that you mentioned, like retries and, I guess pulling things from a queue and just some kind of a resiliency, if you like restart your app and there's like some jobs that have not finished that are retried and all that. I think those features are just like a higher level, at a higher level. If you, so for example, Sidekick uses thread, like that would maybe be comparable. Like what if you built some kind of a background worker system built on async? That would be comparable, right? So hopefully that makes sense. I think comparing a Sidekick with async does not really make sense. You would have to maybe go lower level and compare threads with async, right? That said, if anyone is asking if there is a background job system built on async, there, to my knowledge, there is no such a gem has not been written, right? Right now, async does have a core gem and a pretty rich ecosystem of other gems, that can work really nicely in an asynchronous way. But like a full-fledged background job worker that you can just plug into Rails and it works. No, currently no. One thing to say when we're talking about Sidekick, I think you can really nicely use async within Sidekick. So if you have a need to make a large number, HTTP requests, and you choose Sidekick, you can still use async within Sidekick job to kind of speed things up and to not clog your Sidekick queues and similar. So,
yeah, I guess I was getting at with the comparison of Sidekick is, I forget the library, but I think it's by Evil Martians, where they allow you to kind of batch similar jobs together to process them in bulk. And so I'm wondering maybe if there could be some kind of batch queuing system, like you were saying, that could process similar jobs in parallel, just to churn through things faster and keep the queue moving. But going off of the topic of Rails, so I did read in your article that it's not quite ready fully for Active Record. What's kind of left in that? Because I know there are two open issues. Can you speak to kind of where those are and kind of what limitations there are?
Yeah. So, okay. I do have to say a disclaimer. So I'm not, so currently the most experience I have is just raw async, right? Building a plain Ruby app with async so I've not tried to implement async with Rails, right? And as I mentioned, I think currently that's not possible in a classical way, where a Rails app is backed by a classic database like Postgres or MySQL. That said, when it comes to challenges of working, using async with Rails, there's been, I think, to my knowledge, there's one core problem, and that is making active record connection pool work on a fiber local level, if that makes sense. That is at least my understanding. Of course, I'm not an expert on Rails or active record internals. So, in another way, the challenge or the outstanding issue is instead of making a database connection per thread, Rails needs to handle one database connection per fiber. We have not talked about fibers yet a lot, but that's the equivalent of a thread in an async paradigm. So in a Rails app that is working with async, a single HTTP request would be handled not in a single thread, but in a single fiber, right? So if you think about Puma, of course, it's multi-process. That's standard, but it's also it can be multi-threaded, right? So a single process has, say, 10 or 20 threads. So you can, with a single process, you can handle 20 HTTP requests in parallel. If you work with async, if async was supported, a parallelism that could be achieved would go much, much higher, right? And the reason for that is that because fibers are way more cheaper in terms of resources than threads. A common standard recommendation for using threads is, okay, if you want to go, large, you can go 50 threads in a single process. Maybe you can push it to 100 threads in a single process, but that's pretty much it. If you go above 100 threads per Ruby process, you either know what you're doing and you're like expert on it, or you're just like wrong. So that's the story with threads. When it comes to fibers, you can have, like, I think I've heard people talking about low level millions. So, a single Ruby process can work with a low level couple million fibers at the same time, right? Of course, it has to be a special use case, right? It does not apply to all the scenarios. But the parallelism that could be achieved in a Rails app is much higher than with threads. Of course, that's still kind of theoretical. We first need to kind of iron out those outstanding Rails issues and really try it out. But the kind of promise is like really interesting, to say the least.
All the talk of Puma not necessarily supporting it. Out of the, because I know it has some limitations on what it supports with HTTP2. But so how does somebody use async, right? Like, what do they need the latest Ruby to be able to take advantage of it? Like, is it backported to a certain point? Is there like kind of a bare minimum criteria you have to have before it even makes sense?
Mm-hmm. Mm-hmm. That's a good question. All right. So look, I mean, as I mentioned a couple of times, async is a really low level interface, right? It's related to Ruby threads. So the question may be like, what can you do with threads? Like, you can do many things. You can be on the server side and handle many requests in parallel, or you can be on like the client side and make many requests in parallel. So before maybe tackling the question directly, I want to talk there with async. You can do the same thing, right? You can use the raw async library and just maybe do whatever you want in Ruby with it. And then there's like also async HTTP gem. That's like an kind of powerful HTTP library that's it could be used as like API client for making requests, right? That's one approach. Also, there's Falcon, the gem that's really written around an async core that you can use to handle, of course, handle HTTP requests. There's many things that can be used with async, and it's a pretty low level primitive in Ruby. So back to maybe your question to answer it more directly. I think Ruby 2.6, I think, is supported, but there are some limitations. For example, if you want to make HTTP requests asynchronously with Ruby 2 something, right? Any Ruby 2 library, you would have to use async HTTP. So that's another library, right? Now, if you are on Ruby 3.0, you do not have to depend on async HTTP. You can only use async gem, and using any other HTTP library is supported out of the box because of the fiber scheduler feature that was merged into Ruby 3.0. Mm-hmm. So, for example, you can, use async and you can use net HTTP that's built into Ruby and make asynchronous HTTP requests with it, but you also have to just depend on the async gem. So that's Ruby 3.0. The only kind of hard dependency is the core async gem. Now, if we move on to Ruby 3.1, there's nothing new, I guess there are a couple new features there, but I think you still have to depend on the async gem. So yeah, I think that's kind of the direct answer, right? 2 point something Ruby, yeah, you can work with async, but you kind of need to depend on more gems. Whereas in Ruby 3.0, the only hard requirement is the async gem itself.
So in your great RubyConf talk, you kind of walk through a lot of the, I guess, how async works, right? With the event reactor and fibers and the fiber scheduler. So it kind of seems like, because I know you made kind of a comment in one of your articles about Matt's regretting making fibers.
Yeah.
And it seems like, almost seems like we're coming back to liking fibers now that some improvements have been made.
No, I think I have to correct you. So Matt's never said he regrets making fibers. Matt said that he regrets adding threads into Ruby. I think that's a big difference, right?
Oh, yeah.
So threads really are really hard to work with directly in Ruby because of their inherent complexities, But fibers, yeah, I think that's a different story. So yeah, I think a lot of these things, async and fibers and, fiber scheduler, event selector, those concepts are pretty hard to talk in the Ruby community, just for the reason I think us Rubies, we're just not accustomed to working with these things. We're not used to working with, so for example, event selector, right? I don't think a lot of Rubies even know what it is, right? So just to clarify, event selector, I'm thinking something about EPAL on Linux or KQ on a Mac, or even newer IOU ring on Linux, which is like a hot new technology. That's not relevant for us Rubies. Like we're living in like a Rails land, or just like a Ruby objects land. Like we don't concern ourselves with EPAL. So async brings these things, benefits of these concepts into Ruby. And it's kind of hard to, kind of spread the news because not a lot of people know what an event selector is, Same thing with fibers, how many Rubies really understand fibers? That's like a really, really low level technology. So yeah, I think in order to, for people to understand the awesomeness of async, we kind of have to, dig into, a little bit into these, harder topics, But yeah, did I digress?
No, you're fine.
Oh, thanks.
So how do you go about testing your async code?
Mm-hmm. Well, I think testing async, I think honestly, it's just nothing special. You just use RSpec, of course, or Minitest if that's your thing. I'm an RSpec guy. And, my current approach has been just like a high level integration test. And really, there can be a scenario where you do not even have to have anything specific to async in your test. Like you can just test your code as a regular Ruby code, right? Your tests do not have to know that, back to the standard common async example where you're making 5 HTTP requests in parallel. Your RSpec or your test do not have to know that you're making those requests in parallel as opposed to synchronously, right? Like, unless you're, of course, making like some kind of time based expectations in your tests. But, if you go back to common examples, like in RSpec, you just want to make sure that you made those 5 requests, for example. And if you just plug in VCR, again, your RSpec code does not even have to know you're using async. In fact, I feel comfortable saying, like, if you, for example, for some reason, clear out async, use threads, for your basic API client example, your specs should all pass, I think. So, that's it. I guess, you were asking, like, you could ask if there's anything else. There is, like, if you're using advanced async, if you're, for example, I've written a library with async. So then again, if it's built wholly around async, of course, you would have to, your specs do have to know that it's an async world. So there is an RSpec async library, or is it async RSpec? I kind of forgot. So async RSpec or RSpec async, made by the same creator as Async Ruby, and it has a couple simple assertions that you can use to you just more easily test your async code. So, that's it. If anyone is interested in testing your advanced async code, there is this library that makes it a breeze.
All right. So my question for you right at this moment is, it kind of has to do with like workloads. And we've talked a little bit about why you might choose to use async or whatever. And I feel like for me, what's really important, like when I'm talking about parallelism to other developers, is kind of describing what the problem is. I feel like that's like the only way that I've ever been able to successfully communicate some of this stuff with people. So the thing that I'm thinking about kind of harkens back a little bit to Valentino's question earlier, which is, what kinds of workloads do you feel like work well with async? So for example, you've talked a lot about like HTTP requests. I'm going to make a ton of HTTP requests in parallel. And I'm thinking about use cases for the most part where I make a bunch of requests, but then maybe I parse all of them, or maybe I'm adding records to my database, right? And that kind of use case happens to fit really well, for example, just shoving it into Sidekick. So the thing that I thought of, I was like, well, maybe I do a bunch of HTTP requests. Like maybe I'm checking statuses, right, of a bunch of pages or something. So I'm literally just grabbing the HTTP status or something. Could you talk a little bit about like maybe what use cases would make sense with like this kind of low level parallelism, right, versus like the sort of high level abstracted parallelism that throwing something in a Sidekick queue is giving us?
Yeah. Okay. So I heard you, John, but unfortunately you were choppy again. So what I heard, the part that I heard was, what kind of workload is a good fit for async? I think that's a good question. And then another thing, it was about Sidekick, but unfortunately I did not understand it well because of the choppiness. So maybe I can answer the first question, and then if someone can please repeat the second part. So about what kind of workload is good for async, it's a good question. So I think any IO bound workload is just awesome for async, right? As opposed to CPU bound. And what do we mean by IO, right? Of course, it's making or receiving or handling requests. It could be HTTP, it could be something else. That is just an awesome fit for async, especially if you're not making a lot of use of the CPU. That's a fantastic fit for async. On the other hand, if you have a lot of heavy duty CPU processing, maybe you're like, generating PDFs and it takes a lot of time. Stuff like that, it's not a good fit. It's not a good fit. And maybe not to answer the question shallowly, maybe I can go just a tad deeper into it. So async is using, we mentioned fibers, and fibers, they work in a paradigm that's called cooperative concurrency, right? And that is opposed to how threads work, where each thread gets a fixed time execution, and at that point it stops. It's interrupted by a thread scheduler, and another is then resumed, right? So with threads, you could not have a scenario where you have 50 threads and just one thread is taking up all of your CPU resources and just working indefinitely. That cannot happen with threads because you have a thread scheduler, and after a certain number of milliseconds, that thread scheduler saying, okay, thread number one, you stop now, and then resume another random thread that you have going on. Now, that's the scenario with threads. With async, you have these fibers, and what can happen if you throw a CPU heavy workload into async and into fibers, a single fiber can really clog your CPU. If you start working some heavy CPU intensive computation, a single fiber can just work on it indefinitely, and that can clog all of your other fibers. So the reason for that is because with this cooperative paradigm, a fiber has to voluntarily pass, the execution to some other fiber, and that does not happen explicitly, right? It's not that in your code you have, okay, we are on async fiber number one, and then we pass it to fiber number two, for example. No, that happens in these, like, we can call them yield points. For example, if a fiber number one just finished making the HTTP request and now has to wait for 200 milliseconds, well, in that case, the fiber scheduler will say, this is a good point where for 200 milliseconds or even more, we can transfer the context of execution to some other fiber that was waiting. So that's a different paradigm. And yeah, I mean, I think I kind of dug deeper into why maybe, these fibers in async are more like better for IO based, IO heavy workloads as opposed to CPU heavy, right? Of course, you can still do CPU computations within your async tasks and all that, but I think that's the only thing that you're working with is CPU computation. That kind of does not make sense. Hopefully that answers the first part of the question.
Hey, folks, I'm here with JD from Raygun. JD, we were talking just a second ago about empathy, and it seems like a common concept within the programming community. And yet, when we're building features for customers, a lot of times we call it done when it passes CI, deploys, and doesn't give us errors. And that really doesn't seem very empathetic when it comes to our customers because we're not looking at what they're doing. Do you have thoughts on this?
Yeah, absolutely. I mean, at the end of the day, until your code actually hits the customer, you don't really know if it's any good. Everybody uses things in so many different weird and wonderful ways. You can only really debug in production.
Yeah, I've been there. It's done.
Here.
It's not done. Oh, crap. It's not done. I got to go fix it. Now it's done.
Yeah, absolutely. And when we see things like error reports flowing into Raygun,
right,
a lot of the time it's things where you just kind of go, oh, that was a configuration that as a developer, I didn't think could exist, but actually here's an example. And so it's connecting that code to customer and your development team through to real users and their experiences, which, to your point, builds real empathy, and the best software teams care a lot about how their customers are experiencing their software.
Right. It's kind of the feedback from the app, but it's also kind of this meta feedback. As we do better, we tend to get less of this negative input back from our customer, which really does reflect empathy.
Yeah, absolutely. And I also think, to your point earlier about CI/CD pipelines, like we've done an amazing amount of work as an industry to automate getting to prod really fast. But if you really want to go super fast, you need to close that loop with real-time feedback from prod back to the dev team. And that allows them to do things like fail forward and just really leverage that investment in CI/CD, and it can turn into a real superpower.
Yep, absolutely. So I'm going to encourage you folks, set up your CI/CD, but then go sign up for Raygun. They'll actually give you a free trial, and you can get it at raygun.com.
Now, can you guys please repeat the second question, or maybe we can move on to something else?
Yeah, go ahead and ask the second part, John.
I'll re-ask it, and if he can't understand, any chance one of you guys could rephrase it. So what I was trying to ask was, kind of earlier we had talked about Sidekick as sort of like an high-level abstraction of parallelism, right? And my thought here was, so you talked about in your article and today HTTP requests and parallel, and so a network IO request, and I guess file IO probably fits this bill same way. But I was thinking, okay, so we often use Sidekick as sort of like that high-level abstraction, where I'm like, oh, I'm going to make 100 HTTP requests or whatever, it's 1,000, million, whatever. And I want to parse my responses and do something with it. Maybe I want to drop something in a database or whatever it is, right? So, but I have work to do after I get it back. And so I can parallelize that whole process on a per, basis by queuing up a million Sidekick jobs. And I was just kind of curious, like for me, I'm thinking, okay, maybe a good fit for async versus Sidekick is like, no, basically, I guess more or less what you said, right? Like no CPU processing time here, right? Like I just want to grab the HTTP status or something. So I kind of lost my question, so I had to rephrase it and rethink it through.
Could you guys please repeat because it was choppy for me?
Yeah, I caught the first part of it, and then I couldn't understand the last part of it.
I think I know what John is talking about. So, like, currently we have like this abstraction of Sidekick where you just throw a bunch of stuff at it onto the queue, and it'll work and churn through it sort of asynchronously as pull jobs off as they're available. And that's kind of like the approach people have taken when they want to background something, a group of processes. And so what I guess is the advantage of like, is there some differences between those ideas or advantages over using like async versus just having a background processor? Does it like, what's the value, I guess, of having the async versus having something like Sidekick to process jobs? Like, is there now no longer a reason to have Sidekick around now that we have this new Fiber scheduler and async to kind of do these things that it already does?
Right. I think it's a good question. I think that's so to be clear, I think Sidekick still does have its place for sure. Like there's like, I think no way async can invalidate that. But yeah, let me think about, I'm thinking how the best approach to be answering this question. So, okay. So I heard John like ask this question, like if you have a million HTTP requests, you just enqueue million Sidekick HTTP jobs and just let it churn and you're good. That's how would you currently do it in Ruby. That's fine, I think. What async can improve is really, I mean, maybe I can't really talk abstractly, but like, let me say this. So what I've built, part of my project with async, I've built a crawler, right? So I think it's exactly the use case you're talking about. Like I'm trying to crawl a website that has like 10 million pages, right? So I practically have a queue of 10 million requests to make, right? Where async comes into place is it's just much more. It's like I can easily make a couple hundred HTTP requests in parallel. Whereas I think on a single CPU, by the way, right? Whereas I think, for example, with Sidekick, I do not think it's advised. I think the maximum parallelism, like the maximum number of threads per Sidekick process is, I guess, around 50. So I think that's like a simple answer. Like async allows you, and that's just talking about a single CPU, right? If you kind of scale it up to multiple CPU, you just, multiply the benefits or, we're not talking about multiple, multi CPU. We're just talking